less than 10 miles from here, in the dunes from Marina del Rey all the way down to the Palos Verdes Peninsula, is one of the smallest endangered species in the world, the El Segundo blue. Now, these butterflies are part of the California floristic province, one of only 36 biodiversity hotspots in the entire world, making their conservation especially impactful. Moreover, since its inception, not a single insect species has ever been delisted from the endangered species list. Our project is to evaluate whether or not the El Segundo blue could be the first, serving as a landmark for insect conservation and hopefully staving the species off from extinction. Thus, we're honored to present a pathway to the recovery of the El Segundo blue butterfly. I'd like to make some introductions. Our U.S. Fish and Wildlife representative is Dr. Eric Porter. Our faculty advisor is Dr. Travis Longcore. I'm Alex.
I'm Ryan.
I'm Gianna.
I'm Rashida.
I'm Eden.
I'm Kennedy.
I'm Megan.
I'm Corinne.
Before we get into the details, a little bit of background information. The life cycle of the El Segundo blue butterfly, here known as the ESB, is highly specific. They feed on a single host plant, the sea cliff buckwheat, and they spend their entire life cycle circling around it. The ESB lays its eggs on buckwheat flower head, where as a caterpillar, it'll grow up eating the buckwheat before descending into the sand below. After a few months, it emerges as a fully formed butterfly, but only for 1 to 2 weeks, where it lays the eggs and the cycle begins anew. As you can probably imagine from such a highly specialized life history, degrading the dunes and the sea cliff buckwheat is analogous to harming the butterfly itself. As such, threats such as habitat loss from urbanization, invasive flora such as ice plant, as well as climatic factors such as droughts, can all significantly hamper the recovery of the El Segundo blue. As a result, the U.S. Fish and Wildlife Service designated the El Segundo blue onto the endangered species list in 1976, and while since then a lot of efforts have been made, there's still a lot of work to do. Here are the criteria that are required for the species to be considered stable. To downlist the El Segundo blue from endangered to threatened, first there must be a secure and permanently protected population within each recovery unit. Additionally, all 4 habitats must be managed with native vegetation and sea cliff buckwheat, and all 4 must show a stable or increasing trend for at least the next 8 years. Additionally, a public education program must be instated in order to teach the public about the El Segundo blue, as well as habitat. In order to delist the El Segundo blue from the endangered species list entirely, 4 additional secure and permanently protected populations must be included, and all of the other criteria must also apply. There are 2 parts to our project. First is evaluation, where we gather data, both legal and on the population. And second is recommendations, where we work with the U.S. Fish and Wildlife Service to recommend the best course of action for eventually delisting the species.
So going back to our recovery criteria, the first demands that a securely and permanently protected population exists in each of the recovery units. In order to fully understand this, we needed to understand the legal mechanics of each of the recovery sites. So to do this, we identified all pertinent legal contacts, and then alongside all of supplemental documentation, we evaluated how all the sites held up to their criteria and noted any loopholes that would allow them to abstain from fully fulfilling their conservation duties. Based on this, we then identified all the necessary action that needed to be taken for each of the sites, using sites, especially those in Palos Verdes, as models for others. The second of the criteria demands that all the habitat that is within these sites be managed with native vegetation with a higher emphasis on sea cliff buckwheat. To do this, our team conducted field assessments and cross-referenced our findings with satellite imagery to fully understand the full extent of the habitat and sea cliff buckwheat in each of the sites. Additionally, our team also noted the condition of each of the habitat, especially the presence of buckwheat and also invasives such as ice plant. Based on this, our team formulated recommendations for improving habitat quality and used sites, especially those from the Torrance recovery site, as models for others as well.
To determine the recovery progress of each population for criteria 3, we analyzed all available survey data for all 10 sites. The graph on the right shows the history of the largest ESB population, which is found at the LAX Dune Preserve. We found a pattern where prolonged periods of drought resulted in decreasing populations across the board. A severe drought occurred in 2012 to 2016, which is shown in red on the graph, and as you can see, the LAX population suffered a steep decline during this period. However, the increase you see in the more recent years directly followed habitat restoration efforts. For all sites, successful habitat restoration has led to population increases and even the recolonization of new sites. Both patterns demonstrate a direct link between habitat quality and the overall condition of the ESB populations. During our analyses, we determined two important things regarding the species phenology, or the timing of its summer flight season. The points on this graph demonstrate the day of year that a peak observation had been made, where higher values indicate a later day. We found that populations in the southern sites, shown in blue, emerge earlier than those in the north, shown in red, by a difference of around 20 days. The second thing that we identified is that over time, the ESB as a species is emerging sooner. This graph illustrates a total difference of 30 days over the course of only 40 years. We determined that this drastic change is likely an effect of climate change, which is causing summer to occur earlier each year. These are both novel findings and have allowed us to expand our understanding of the ESB as a species and learn how to more effectively monitor its populations, which we'll go into further later.
The fourth and final of the recovery criteria demands that a public educational program is established for the community members to be involved. Currently, there are some successful endeavors that are established, including restoration events and long-term community restoration programs being undertaken by nonprofits such as the Friend of Idaho Wetlands and the South Bay Parkland Conservancy. Additionally, the Los Angeles Times has covered this butterfly a lot and has developed a strong online presence for it. Some areas that need improvement, though, however, are a strong outreach program and an incentive for outreach and a centralized network for that, as well as proper signage for trail and habitat prevention from disturbance. We also developed thorough site assessments that had details on the population status, the condition of the habitat, and all the legal protections for all of the sites that we looked at. Based on this, we also developed 5 key sites that had the highest potential for recovery. And based on that, we also developed guides for future conservation projects that will be used in the future. And finally, we also developed some recovery plan amendments, the biggest of which is the addition of the Palos Verdes Recovery Unit. This recovery unit would provide additional protection for the species, increase the current range of the habitat, and help and preserve the unique genetic diversity and the overall species and health of the species as a whole. Based on this information, we are giving recommendations to the U.S. Fish and Wildlife Service to update the recovery criteria to match ours to further streamline the downlisting and delisting process.
When going through the population data, we ran into several issues due to late surveys, gaps in survey years, and the inconsistent usage of survey methods. To address these problems, we created a standardized monitoring methodology that would allow data from all sites to be directly comparable. Surveys are to be conducted annually according to a specialized schedule for each site, created from our analyses where we estimated the peak of their flight seasons. By collecting reliable and consistent data, the recovery progress of each population can be more easily tracked to guide future actions. All of our research comes together to formulate a recovery strategy. We have devised a plan to allow for the ESB to make a full recovery within the next 10 years, to the point where it can be safely delisted from the endangered species list. The plan centers around accurately monitoring populations, solidifying protections for the known sites, restoring and managing habitat, and involving more of the community to further increase awareness and volunteer restoration efforts. If implemented accordingly, the ESB could become the first insect species to ever be delisted from the endangered species list. Enormous strides have been made over the past few decades, with widespread population increases and the recolonization of several sites, all thanks to grassroots restoration and conservation efforts. Our recommendations give U.S. Fish and Wildlife and landowners the framework that they need to continue this work in the most effective and focused manner possible. Ultimately, the team has found that the El Segundo blue butterfly has shown incredible resilience and has a great promise for a speedy recovery if only given the opportunity. If this highly endangered endemic urban butterfly can come back from the brink of extinction, it would set a hopeful precedent for the future of conservation during the time where we need it most. We would like to thank Dr. Eric Porter, Dr. Travis Longport, and all other parties involved in making this project possible. Thank you.
Something hopeful for the future here. Question to Ryan. maybe speak a little bit to, do you think any of the methods you developed could be generalizable? Like, let's say another group went out and looked at endangered species or something that was listed, and let's say a plant, obligate insect, was it so specific to El Segundo that you wouldn't be able to make recommendations, or did you kind of pick up lessons from the field that might be applicable to other systems?
I think that some of the recommendations that we made could be applicable to other species, but these were highly specific recommendations based on each site, based on specifically this species. But in general, yes, it could be applied to others.
Excellent. Well, thank you, team. This is really remarkable, and I'll look forward to seeing in 10 years when this gets delisted.